A new invention created to aid paraplegic individuals has yielded promising results during a trial after 3 patients completely paralyzed from the waist down were able to stand up and walk using the aid of wheeled frames or crutches for support, as well as cycle and swim. The patients, males aged 29, 32, and 41, were reported to have injuries to their thoracic spines, which is the region of their spinal cord below the neck and above the lowest part of the back, after suffering motorcycle accidents, and had been paralyzed for between 1 to 9 years before getting the chance to try out the new coming in the form of an implant inserted by neurosurgeons. The device works by using electrical nerve stimulations controlled by an external touchscreen. Tableton aided by artificial intelligence, AI, software. A paralyzed patient training to walk again after receiving the implant. Image. Reuters. Within an hour after the surgery, the patients were able to take their first steps, and over the next 6 months, they were even able to take on tougher tasks such as cycling and swimming in controlled environments outside the clinic. According to the researchers, all this was done by the patients themselves, with the help of touchscreen tablets. A pathway for overcoming paralysis. In perfectly healthy individuals, body movement is initiated after the brain sends a signal to the spinal cord, which then stimulates the appropriate nerve cells to activate the necessary muscle groups. But following heavy injuries to the spine, messages from the brain are prevented from reaching the nerves altogether, which has so far proved to be a major stumbling point in the rehabilitation of paralyzed patients due to the inability of the spinal cord to heal itself. Previously, other studies have attempted to find a solution to the problem by stimulating nerves through the rear of the spine, but with limited success. This particular study, however, used the approach of sending electrical signals through the sides of the spine instead of from the back, which allows for more precise targeting and activation of the spinal cord's different regions. The system is also complemented by AI algorithms that are tailored to the individual, and allows the user to send specific instructions through the implant to trigger select nerves. For example, a patient could hit instructions such as sit or walk on the tablet, and then have their body respond appropriately as the system sends the signal from the tablet all the way down to the muscle controlling nerves. The first few steps were incredible. A dream come true. I've been through some pretty intense training in the past few months, and I've set myself a series of goals. For instance, I can now go up and down stairs, and I hope to be able to walk 1 kilometer by this summer. pic.twitter.com/asozav4k. EPFL, at EPFL_N, February 7, 2022. The project was spearheaded by Grégoire Courtine and Jocelyn Bloch of the Swiss Federal Institute of Technology in Lausanne, who have already established a company called Onward Medical to commercialize the system. Within the next year, they plan to launch trials involving between 70 to 100 patients and confirm the results found on the 3 early testers. Read more life stories. Villagers finally free crocodile from tire around its neck after 6 long years. Watch as schoolboy patiently negotiates with 2 monkeys holding his bag hostage. Sleeping 1 extra hour reduces calorie intake in overweight people, study finds. Cover image sourced from The Mighty.